So NLP in future could generate press releases, and it can write books, and it can even write a SAT test. For example, like somebody who to know how to write a SAT test, if you were to give an NLP, it can take the entire SAT test and come with a top marks.
Welcome to a whole new episode of Ingadi CX. I'm your host, Jeremy D'Souza, and today we're going to be talking NLP over here on the Ingadi CX show. But before I introduce you to our amazing guest, allow me to first introduce you to the magic of Ingadi. Ingadi is the world's leading multilingual no-code chatbot platform, available across 14 channels with 30,000 bots created across 186 countries in every domain and use case. Ingadi has been recognized as a top platform by Inc.com, TechWorld, CIO, and many others. We run the Ingadi blog, video channel, and the Ingadi CX podcast, receiving upwards of 300,000 visitors annually. Now for our amazing guest. GP is a distinguished technology leader, providing innovatory solution architecture, enterprise application development, design engineering management, data science, machine learning, deep learning, IoT platforms, and natural language processing. GP has also been ranked fifth as a data science influencer for 2018 by Analytica, and Joe Fields ranked fourth as a machine learning influencer for 2018 by Kcore Analytics and Hernan Marks. GP, we're really thrilled to have you here with us today.
Hi, nice meeting you, Jeremy. And so today we're going to be talking about NLP, right?
Yes, we will be talking NLP. But before we get started with our interview, I just got a quick announcement for everyone who's watching this, everyone who's listening. Because all of you tuned in, we have something special for all of you. So stick around till the end of this interview and you'll get your free gift. GP, let's get started. Let's dive in.
So today, the natural language processing has been there from 1950s, and primarily it consists of the AI, semantics and linguistics, and that's when it all started in 50s because people used to write, so many programs in terms of like hash coding millions of rules, and it was a rule-based natural language processing back in the day. And that's what primarily, the inner workings of the NLP used to be, because it was powered by the statistical machine translation, and it wasn't having any sophisticated and advanced natural language processing abilities back in the day. Yeah. And then it wasn't, that faster, because it was again a winter of AI that came in and that slowed down a lot of activities because people weren't sure if it's going to make a lot of progress in terms of how the NLP is going to evolve in the next few decades. But and again, all of a sudden, it has picked up some huge momentum as the NLP started progressing, picking up the deep neural networks. The deep neural networks are really revolutionized the way that NLP powers a lot of applications, and people started installing these applications on their mobile phones, or any of advanced NLP processes for customer services, and many of the fields of engineering where people could really leverage these DNNs. So the advancement we see starting in NLP, basically starting from the DNNs. And then again, after the DNNs, they started going towards the math. Instead of applying the stat to get the results for the NLP, people started moving towards the math side of it. And the math side, primarily, they started with word-to-vector. So word-to-vector was one of the first models that was invented in 2013. And so word-to-vector is primarily, like, for example, in math, we have tensors. So the tensors, you have primarily scalars, vectors, and we have matrices, and then we have tensors. So the way that word-to-vector works, it primarily takes words and then converts them into a vector. So A scalar is primarily an array that consists of a single element, and the vector it primarily consists of at least a couple of elements in the array. And then when we're moving to the matrix, it has like three-dimensional arrays, and we're going for it turns out it could be n-dimensional arrays. So basically, the words are represented in a vector, and then simply it does apply the word embedding technique and builds the word vector so that the translation occurs pretty quickly. And also, it can predict what is the next word that is going to be. And that's how the word to vector has revolutionized the NLP space. And a lot of implementation that came out on this, from Python and TensorFlow, or it could be PyTorch. A number of programming languages in machine learning have revolutionized the word to vector. And then, the researchers also have come up with some additional NLP models. For example, we are talking about bag of words is another NLP technique. And there is also, something that's called skipgram. So the skipgram and the bag of words have again revolutionized, moving away from not only just going with a vector-based approach mathematically, but we are also now shifting the gears towards taking a bunch of text and then breaking it down into paragraphs and breaking it down into words, and then how we can efficiently process this entire text efficiently. So again, after the invention of RNNs have further revolutionized along with the CNNs, the convolutional neural networks and recurrent neural networks together have powered the natural language processing on the frontiers of mathematics. With they came up with another model called sequence to sequence. So sequence to sequence is again another revolutionary NLP technique where there was a research paper on sequence to sequence, and so primarily taking the recurrent neural network and processing it. So it gave so much of opportunity to introduce so many neural networks, and you can process as much of text as you want. I mean, it doesn't limit people to process the text. And then again, as we progress further, now what happened was Google, that has been implementing all of their machine translations through the statistical translations, have shifted towards neural machine translation. The neural machine translation is another technique where now we are progressing towards applying the math towards the NLP, and then again applying it through the deep neural networks and recurrent neural networks. So primarily, when it all started happening, the neural machine translation gave the ability to power the NLP with millions of parameters from Google. And again, Google started another NLP architecture process called Transformer. And the Transformer has again revolutionized the entire space of the NLP area. And the Transformers again moved towards further models. For example, we're talking about the BERT. The BERT is, again, a very sophisticated NLP technique over the word-to-vec and bag of words and skipgram and the sec-to-sec model. So the BERT, again, had some millions of parameters on it, and that was able to read any text from anywhere and produce the type of outcomes that people couldn't possibly thought was possible. Then again, moving forward with the BERT, again, BERT large was constructed that was like even much larger than BERT, like millions of parameters we could leverage, and people could construct that type of text to translate any text from any language to other language in fraction of seconds. Again, the volume could be huge, and they can process any amount of text. So again, after all of these developments, and some of the most brilliant and brightest minds of NLP from the past decade have come up with these sophisticated architecture models, and then people have started moving towards building an AGI for natural language processing. Again, nobody thought that people could advance with marching towards the AGI, artificial general intelligence, and achieving the singularity where it's completely unsupervised. Basically, the program itself can ingest the data and provide the outcomes that people are looking for. And so that's when companies like OpenAI, for example, have started implementing some of the NLP techniques. And again, there's another company, NVIDIA, also have come up with not only natural language processing, but also natural language generation. Again, the natural language generation from NVIDIA has come up with the Megatron LM. So the Megatron LM is basically an advancement of natural language generation machine that can produce any amount of text with, millions and millions of parameters. And again, Google has come up with an advanced transformer technique called T5. And T5 has billions of parameters that can process this type of natural language processing. And again, Microsoft has come up with another architecture called Turing NLG, which is basically Turing natural language generator. And so the Microsoft has 17 billion parameters and NLP that has produced, the outcomes from natural language processing. And moving towards OpenAI, OpenAI again has brought their models, for example, GPT. The GPT has 110 million parameters. And again, the next generation GPT-2 has around 1.5 billion parameters. And the next generator is called GPT-3, which is primarily having 175 million parameters of natural language. So what we're talking about here is like it can pretty much pick up the entire text from the whole internet. It's not like, there are different types of techniques. Like, for example, we're talking about zero-shot learning, or we're talking about few-shot learning. So in zero-shot learning, what happens is that it doesn't have any idea about the text and there's no input. It can predict the outcome based on several combination of dictionary, and it comes up with, okay, this is what the word is going to be. So it doesn't have any precedent or any historical data where it gets the inputs to perform this type of mathematical calculations to produce NLP. Coming to the few-shot learning, at least there are some instances of text that gives some samples and understand how to build the paragraphs or how to build the text, and that's another technique of NLP. That's a few-shot learning, where a lot of stuff can be produced in terms of getting the data. So the GPT-3 with 175 billion parameters, if somebody were to process it like manually, the type of scale that it processes is just amazing. Because if we are looking at a computer to do it, a computer research group called Lambda mentioned that, if we were to do this, if OpenAI is not going to do it, if we were to do it, this is going to take 355 years and 4.6 million hours of processing, and we need GPUs, and we need such a computing stack that human people cannot possibly produce this type of outcome. So the GPT-3 is so advanced that in the human brain there are around 87 billion neurons, and again there are 100 millions of synaptics and 500 trillion synaptic connections from each neuron. So that's the advancement of human to gear towards the AGI. And if you're looking at, the GPT-3 is just behind 1,000 times lesser than the human brain. So as OpenAI starts building more and more NLP, that you can see, so many outcomes from these NLP advancements. So for example, like there are already NLP machine learning programs that have written books, and NLP machine learning programs that have written articles. Just by taking the title of the newspaper headline, it can produce the entire article, or just taking a few sentences from a particular draft of a book, it can produce a chapter of how the chapter is going to have to look like, or what are the topics in it, or and then again, that's the way that the NLP is evolving. And again, other than the
You
yeah.
mentioned that NLP can actually let them write a book entirely. What other applications could it have? It sounds really interesting over here.
So NLP in future could generate press releases, and it can write books, and it can even write a SAT test. For example, like somebody who to know how to write a SAT test, if you were to give an NLP, it can take the entire SAT test and come with a top marks because it knows all the answers already. It already has all the answers, and it can build a Q&A generator, and it can come up with so there's no human that needs to explain how this functionality or anything. So that's the type of the advancements we can see from. It's almost like getting towards the singularity of what people said. That's like so many years away from the developing such kind of a sophisticated AGI, but it's already there. And all the things that I was talking about, it's already able to do it, and it is able to compose lyrics, and it is able to compose music, from different people, and it is able to write the books. And so those are the type of things we are seeing from such NLP techniques. And again, Open AI has outsourced their open API for anybody to use it. So it's not like it's totally open source. It's not like something that somebody only having proprietary access to Open API. NLP can do it. So people can just simply go to OpenAI, and then there is a link for Open API, and just say join this list, and send an invitation to OpenAI. And they're going to send an email saying, okay, now you're added to Open API. Then they will provide the entire Open API for the people so that they can just provide a bunch of text, and it comes with the outcome. It's just an input output text type of an interface where you can generate a lot of text, and you can gain insights from what is the input. And for example, as I was talking about, take an article from some newspaper and produce the output of what it is going to be in the next steps. It also will explain the next steps.
You mentioned singularity. What are your thoughts on the concept of singularity in AI? And how far do you think we are from machines actually starting to replicate machines?
So that's what exactly I was talking about. For example, like the GPT-3 is at least 1,000 times below the singularity, right? Because it can only produce, around 175 billion parameters. Again, that's nowhere closer to a human brain, because the human brain has 500 trillion synapses with 87 billion neurons. And that's not something where, this particular type of GPT is advanced. But again, what does it take to get to that point? If we need to develop a true AGI, moving from GPT-3 all the way to something where we are closer to getting to that point of singularity. So that's when we need some advanced neural networks. And again, we have some limitations on the computing hardware, computing stack, in terms of how much it can process, the ability of the text from the whole internet, and how can it produce the outcomes, because it has to build a knowledge, the entire repository of all of the text in the world, and then it'll be able to produce the type of thoughts and ideas similar to human. And that's when it can actually be able to provide the outcomes. And again, this is something we have to get to the singularity. Then it has to be like some GPT 1,000. I mean, the GPT-3 is not going to do it. So we are definitely 1,000 times behind the singularity right now, where we can say AGI. Again, AGI is it can be applied also through reinforcement learning for natural language processing, so that it's completely reinforcement learning. There's no supervised learning. There's no unsupervised learning. It just takes the data in its own. It builds the data pipelines of the text, and it builds the distributed capabilities and process the text, and it provides the outcome. So for that, yeah, definitely we are not there yet, but that's the gap right now we have between GPT-3 versus the singularity.
That's really, really mind-blowing. GP, you are an author, you are a writer. Are there any interesting books coming up from you?
Yeah, so basically, working on a couple of books because implementing a project is different from writing a book because most of the project we implement for the customer is not something that you can ever release anywhere because you have an NDA, you have confidentiality. So the only way that I want to get all of these, techniques and processing tools and the frameworks and how to do the implementations, all of that through the books. So that's where I would like to release them so that people can leverage these techniques. It's just more like the techniques of machine learning and how to implement them and all that. So yeah, working on a couple of books and that's something that should come out soon. And so again, for NLP, the fundamental building blocks for the programming are like, there are a lot of things that people can work on different types of libraries. For example, Python offers something called NLTK, which is a library for it. And then there's also another library called SpaCy. And there's another library for Python called Pattern. And Pattern also produces a lot of natural language processing elements. Taking advantage of all of these techniques, people can produce some outcomes in the machine learning. And again, it has different types of techniques. We have lexicology, we have syntactic analysis, we have semantic analysis, and we have different types of analysis to break down the text into different words, and then again apply the vectors and produce the outcomes and all that. Again, there are different types of processes that are involved, like part of speech, and again, tagged part of speech. And then there is a tokenizers. Tokenizers basically groups similar words together, and it can produce the type of outcome we are looking in the NLP. So those are tokenizers. Again, there's another process called stemming. Stemming is also another technique in machine learning where we can process this type of text and produce the outcomes. Yeah. And there's also another type of process called lemmatization. Lemmatization is also an advanced NLP processing technique. And most of these techniques can be leveraged through all of the libraries of Python that I just mentioned to you. And also TensorFlow has their own natural language processing way of doing things. And again, PyTorch has their own way of processing, the natural language processing libraries and techniques. Each of them have adopted their own. But again, if you're going for TensorFlow and PyTorch, it'll be mostly like tensors. They'll be dealing all the mathematical notations, everything through tensors. And if you're coming to Python, it's mostly NumPy arrays. They're much similar in the way that they operate, but it's just a different technique that each programming has adopted. And there's also there's a lot of different, not only the linear algebra, we're talking about vectorizing the words and all that, but there's also need for differential calculus, and then there is integrals and partial derivatives and complete derivatives that can be applied towards the words. And we can also apply reinforcement learning to get the type of outcomes we are looking from the NLP. So that's another way of dealing with the NLP, because when we apply the differential calculus, we're going to get some outcomes, basically that we are looking for. Again, looking at the differential calculus is basically something, the mathematics of differential calculus is all about relationship between multiple variables, right? What happens to A if something happens to B, and the rate of change between A and B. So if A is impacted by something, how does B change based on what happens to A? So that rate of change of the equations is called differential calculus. And this is pretty popular in NLP to apply this type of NLP techniques through differential calculus. And so definitely there are different ways of applying it. Again, reinforcement learning is also another advanced way of doing it, because most of the time when we are doing with the supervised learning or unsupervised learning, so supervised learning will require labeling the data to get the type of outputs we needed. But then again, we are applying something like reinforcement learning. It does not require any such type of data, and it doesn't require any historical data. It operates on its own, and it basically on the environment, it will be able to come up with the type of text outputs. Like, it's almost like zero shot learning, where it doesn't have any text that we are extracting from with a prior distribution of what is the text is to predict what is the text is going to look like. It just operates completely on its own, and it can predict with tokenizers, stemming, and also the lemmatization type of techniques.
Wow. GP, your insights are like phenomenal. Where can everyone reach out to you? Where can they find you?
So primarily, I'm available on different types of social media channels. For example, I'm there on Twitter at GP_Pulipaka, PULIPAKA. And I'm also available on LinkedIn, or I also have a Facebook page, a public Facebook page where I share a lot of research papers and different type of tutorials on how to handle different types of machine learning techniques and all that on Twitter and LinkedIn, as well as on Facebook page, all of these three social media channels.
Okay, you guys have heard it. Reach out to GP on Twitter, LinkedIn, his Facebook page, and you definitely need to stay tuned for his book, which is going to be coming out pretty soon, right, GP?
Yes.
Okay. We did mention that we have something special for all of you, and it's that we have launched our book, our ebook, The Evolution of Customer Experience. It's out, it's available for you to download for free. So hit the link in the description, go check it out. You're gonna love this. And right after that, rush over to GP's Twitter, his LinkedIn, and his Facebook. Engadi CX will be back with a new episode and a new expert really, really soon. So stay tuned, guys.